Hello everyone. In this video, we're going to talk about how do we calculate correlation between two numerical variables. Correlation is a measure of linear relationship between the two variables. And in previous video, we talked about making scatter plot to describe the relationship, including linear or nonlinear. So in our class, we're going to focus on a linear relationship from now on. But again, we can make a scatter plot to describe it, right? And scatter plot can give us a lot of good information that we need, like, the direction of the relationship, the form of the relationship, the strengths of the relationship, or if there are outliers or not. But we just needed more information. The scatter plot can give us a kind of a rough estimate, but we need to have a numerical measure for it. So for example, if you have two data sets, and based on the two data sets, we make two scatter plots, and it both shows strong linear relationship. But if the question is, which one of the two groups give you a stronger relationship? It will be very hard to tell from the scatter plot. So we need to have a numerical measure to tell us how strong the relationship is. And then we can compare the strengths very easily. That's where the correlation comes in. Correlation is we're using R represent correlation R. That's the correlation for the sample. The formula is 1 divided by n minus 1 times another fraction. On top is summation of xi minus x bar, yi minus y bar. On the bottom is sx, sy, and there's a multiplication indicated there. So if you look at the formula, on the bottom here is have n is your sample size. So basically how many individuals are being collected in a sample, that's your sample size. Okay, so here is sample size n minus 1. On the bottom of this fraction on the right, we have sx and sy. So s is, from the previous video, we talk of the S, right? S represent sample standard deviation. Okay. So Sx will be sample standard deviation for variable x. So only look at the variable x by itself. And Sy will be sample standard deviation for y variable alone. So from previous video or previous module, we learned sample standard deviation has a formula of square root of summation of xi minus x bar squared divided by n minus 1. Basically, that's a standard deviation for variable x. And similarly, standard deviation of variable y will be just changing all the x into y, right? yi minus y bar squared divided by n minus 1. Okay, so that's standard deviation of x, standard deviation of y in the correlation calculation. Then on top here is a big summation piece. Okay, so I would recommend everyone to watch the video again for calculating sample standard deviation, because this is a very similar procedure, so that will help you to understand the whole process. We mentioned before, in a lot of the statistic formulas, we have this summation piece, like here, here, here. And anytime you see the summation piece, it will be very helpful to calculate the summation piece using the worksheet, just like the worksheet we designed in calculating standard deviation. Okay. So in this demonstration, we're going to use a small, simple data set just to demonstrate the process. But for any sample data, basically we're going to follow the same procedure to calculate the correlation. So for example, let's go ahead and get started. We're going to design a worksheet, and we're going to start with the two variable x and y. Okay, just list your data. So here basically we have first individual x value equals 3, x equals 1, y equals 3, second individual x equals 2, y equals 4, and so on. So just copy the data over. For first individual, x equals 1, y equals 3, and then x equals 2, y equals 4, x equals 3, y equals 6, x equals 4, y equals 9, and x equals 5, y equals to 13. Okay, just copy your data over. Then we're going to calculate a column total of the x column. So 1 plus 2 plus 3 plus 4 plus 5, just adding all up, that'd be 15. And then this column total will represent summation of x's, right? Basically adding up all the x will give you this. That's summation of x. That's what summation means for any of the summations. Okay, so basically you just need to make a column that's the same as what your summation on, then the column total will be the summation piece we're looking for. So basically summation of xi equal to 15 from there. So refer to back to the standard deviation calculations. This will give us sample mean x bar, which will be the formula of summation of xi divided by n. And we get here summation of xi equal to 15 divided by n, and there's 5. You have 5 individuals. So x bar equal to 3. So that's the column we're going to have next, x bar. We're going to have 3 all the way across the entire column. Okay. And similarly, we can calculate the column total for y column as well. So that means 3 plus 4, 7, 7 plus 6, 13, 13 plus 9, 22, 22 plus 13 is 35. Okay. So summation of yi, basically it's adding up all the y column, give you 35. So from here we can calculate y bar, basically sample mean for y. Similarly, summation of yi minus n will be 35 divided by 5, which is 7. Okay, so that's the next column we have, y bar. We can have 7 across the entire column. Okay. So then we're going to have next column as xi minus x bar. So basically that will be your x column subtracting the corresponding x bar column. So then the first value will be 1 minus 3. That will be negative 2. And then 2 subtract 3, negative 1. 3 subtract 3, 0. 4 subtract 3, positive 1. 5 subtract 3, positive 2. So be careful with the sign. You need to keep all the signs. Okay. Then we're going to calculate another difference. That will be yi minus y bar. So basically your y column, subtract your corresponding y bar column. The first number will be 3 minus 7, which is negative 4. And then 4 minus 7, that will be negative 3. 6 subtract 7, negative 1. 9 subtract 7, positive 2. 13 subtract 7, positive 6. Okay. So we're going to leave 2 spaces here. And we're going to calculate we're going to calculate the column total as, we're going to calculate the column as x minus x bar times yi minus y bar. So you can see this will be the summation piece that we're working on, right? So then the column total of this column will be the summation of that piece. So that's the big purpose of designing the worksheet, to get this. Okay. So then xi minus x bar, yi minus y bar, basically it's going to be xi minus x bar column times yi minus y bar column correspondingly. So the first innovative will be -2 times -4. So negative become positive, and 2 times 4 is 8. So that's the first number. And second number will be -1 times -3. So negative, positive again. 1 times 3, it's 3. And the next one will be 0 times -1. So 0 times any number will equal to 0, right? And then 1 times 2, they're both positive, so it's positive 2. 2 times 6, they're both positive, it'll be positive 12. Okay. So if we calculate column total here, 8 and 3, 11, 11, 2, 13, 13 plus 12, 25. The column total here is 25, which means summation of xi minus x bar, yi minus y bar will equal to 25. Basically, summation of this column equal to column total. Okay. So now when you look at the calculation, we have n is 5. We have this summation piece. All we need is calculating standard deviation of x and standard deviation of y. Then we have all the pieces we need for the entire calculation. Then, go back to the previous calculation for standard deviation. We need to basically create xi minus x bar square column. Then the column total will be the summation piece. Then we can calculate standard deviation, right? But when you look at the design here, xi minus x bar is already here. All we need is make a square of this. We can get that xi minus x bar square column. Then we can calculate standard deviation based on that column total. So we can make xi minus x bar squared column. That basically will be -2, take a square, +4. Watch the sign again. The square column can only be positive number, or at least 0. So -1, take a square, +1, 0, take a square, 0, 1, take a square, 1, 2, take a square is 4, right? So if you get a column total here, 4, 1, 1, 4, and 0, so add up to 10. So which means summation of xi minus x bar square will equal to 10. That's basically from that column, right? And then if we apply the formula, standard deviation of x will equal to summation of xi minus x bar squared divided by n minus 1, which is summation of xi minus x bar squared equal to 10. We placed it in there. N is 5 minus 1 will be square root of 2.5. 10 divided by 4. So if we calculate it, will be 1.58. Okay. So similarly, we can calculate standard deviation of y by creating a yi minus y bar squared. Basically, that's yi minus y bar, take a square. Okay. So -4, take a square, positive 16. Make sure it's all positive number on this column. -3, take a square, positive 9. -1, take a square, 1, 2, take a square, 4, 6, take a square, 36. So then if you can calculate this column total, we have 9 and 1 is 10, 16 and 4 is 20, 10 and 20 and 30, 30 plus 36, that will be 66. Basically you can add it up using calculators. Well, that column total will be summation of yi minus y bar square. Basically add the summation piece on this column that give you column total. Add it up. So that'll be 66. So from here we can calculate standard deviation of y by the formula. Summation of yi minus y bar square divided by n minus 1. Basically copy the formula from here.
Then we're going to place numbers in. Summation yi minus y bar squared, that's 66. And minus 1, 5 minus 1. That'll be square root of 66 divided by 4, which is 16.5. If you take a square root of this, we got 4.06. Okay. So now basically we have all the information we needed for the calculation of correlation R. If we copy the formula down, 1 divided by minus 1, summation of xi minus x bar, yi minus y bar, divided by sx times sy. That'd be put in numbers and equal to 5, 5 subtract 1. On top we have basically the summation piece, 25. On bottom we have sx is 1.58. Sy will be 4.06. So all we need is calculate this, right? So we can put it in the calculator. So I got 0.974. That's the correlation between the two variables x and y. And when you have a different data set, basically it's going to create the same format. You know, when you have more individuals, just keep listing them. But you're always going to calculate the sample mean of both variable x bar and y bar, and calculate deviation x minus x bar, y minus y bar. And then based on xi minus x bar, y minus y bar, you can calculate x minus x bar times y minus y bar. The column total will be the summation piece in the correlation calculation. And then we can calculate the standard deviation of x, standard deviation of y, the same approach as what we did before. It's just we're gonna take a shortcut here. So we can get xi minus x bar squared based on xi minus x bar already calculated. So this number will give you standard deviation of x through calculation. This will give you standard deviation of y through calculation. And correlation is 0.974. It's a positive number. Okay. So like I mentioned in the module, for correlation R, it gives us the sign will tell us the direction of the linear relationship. So this is a positive number. That means the relationship is positive. And the value will give us the strength of the correlation linear relationship. Since it's up very close to 1, so that means we have a very strong linear relationship between the two variables x and y. Okay. So this is how I do it manually by hand. And now let's see how do I do it in Excel. So basically we're going to put data in here, x and y. Okay. So we need to calculate correlation. We're going to say label, this is correlation calculation. So here on the next cell, we're gonna calculate the correlation. So first we're gonna type equal to, and then we're gonna choose the correct function, and it's gonna be called a correl function. So when you type, you know, it's gonna pop up for you, correl. You double click, you know, you're gonna choose it for you. So here you have two arguments in the function, array1, array2. Basically that's your variable x and a variable y. Okay, so all you need is choose the data set. So we're going to choose the array1. Basically, we're going to use x for that. We're going to click on the first value and hold your shift key and click on the last value. That will highlight the whole range of data for you. So D2 to D6. Basically, it's D2 to D6. That's your first argument. And you can see in the function, tell you need to have a comma in between, so we need to have a comma. Then we're gonna put in array 2. So you can either do the same thing, highlight, or instead you can type. You know, the first starting point will be E2, so you type E2 and colon, just like follow the same format, and then the last value will be E6. So you type E6. You can see the same, you know, Y data range is highlighted for you. So n parentheses, so that function is complete. So you hit enter, that gives you the correlation between two numerical variables. So it's 0.973. And it's very close to what we calculated by hand, 0.974. Think about it, we could have rounding errors by calculating by hand. Alright, so this is how we calculate correlation by hand or using Excel. Thank you very much for watching. Bye-bye.